Hello, Assalamualaikum and good morning. We will start soon. Can anybody write in the chat whether you can hear me or not? So we will start now. Okay. Okay. Today we will learn about voltage and current divider rule. Okay. What is okay? Previously we learned about the circuit analysis toolbox. You learn about the Ohm's law, the Kichoff Voltage Law, Kichoff Current Law, series resistance, parallel resistance. Okay. Last week you learned all these 5. So you can use this to solve electrical circuit problem. So there is another theory that you can use to solve this problem. Okay, voltage divider rule and current divider rule. Okay, so you can use all these rules to solve electrical circuit. Okay, so I will show you today. Okay, these two, voltage divider rule and current divider rule. Okay, you can. This is the derivation on how to get the voltage divider rule. So you can see that, as I mentioned before, you know, there is a voltage divider rule actually is for series circuit only. So for parallel, you can use voltage divider because in parallel voltage is the same. But for series, the voltage is different, but the current is the same. As you can see here, all the current are the same. Okay, and this is the formula. Okay, Vn means the voltage across the resistance equals to the resistance Rn, okay, divided by the total resistance and multiply by the voltage at this point. Okay, so this is the general formula for voltage divider. To use voltage divider rule, okay, you can see here, okay, a 50 volt, okay, 50 volt source and 2 resistor, this one and this one are connected in series. Okay, R1, R2 is 3 R1. Okay, so 3 R1, 1 R2. So what is the voltage across this and this? So how to use voltage divider rule? So I copy this. Okay. Okay, this is 50 volt and R2 equals to 3 R1. So remember, you use the voltage division rule. So the formula is, okay, this one. This is the general formula. Okay, now we use that. So we want to find VR1 first. VR1 equals to, so R1, because we want N is the 1, divided by the total resistance is R1 and R2. R1 plus R2. Then don't forget to multiply by the voltage across the series. Okay, this one, for this case, this is 50. Okay, so this example, the value. So just use R1 divided by R1 plus R2 is 3R1. 3R1. 50. Okay. So you get R1 divided by 4 R1 50. So equals to, you can cancel this and this. You get 50, 25, 11, 12.5 volt. So you get the voltage across here is 12.5 volt. Okay. How about the second one? So VR2. Okay, for VR2 equals to R2 divided by total resistance R1 plus R2. Don't forget the voltage 50. So R2 divided by R1 is 1 over 3 R2. Okay, from this. Okay. So R1 equals to R2 over 3 plus R2 50. So you solve this. Okay. You have to make it same. So this come like this, 3, and this one is 4 R2 R2. So you can cancel this, and don't forget the 50. So you get, so use your calculator, is okay 37.5 volt. Okay, this is how you use voltage divider rule. So this is the answer. Okay. Okay. As I mentioned last week, as I mentioned this early, okay, this is just one way to solve this actually. But if you use the theory provided last week, okay, you also can use other method. Okay, you can use Kichoff Voltage Law actually. So for Kichoff Voltage Law, if you use Kichoff Voltage Law, you have to apply the circle using KVL. So using KVL, this one is just one way, one tool you can use to solve this. Or another way is, for if you use the method I showed you last week, you can use Kichoff Voltage Law. Okay, if you can see, do a loop here, mid negative, so negative 50. Okay, then mid positive plus 12.5, then mid plus, okay, plus V2 equals to 0. So V2 automatically you can get 50 minus 12.5. So equals to 37.5. Either you use Kichoff law or voltage divider rule. Okay, it will get the same. Okay, you can use either way. But sometimes the question asks you to use specific way, so you have to follow. Either they want use Kichoff voltage law or voltage divider rule. Okay. So voltage, we have learned about voltage divider rule. Now we learn about the current divider rule. Okay. So this is current divider. So basically, the current here, okay, the current here is divided into two resistors. Okay, so we have the current here. We don't know the current goes through here and the current goes to here. Okay, so we use the current divider rule. So this is a formula used to get the current. So you have to memorize this. Usually in the final or test, the formula is not given. Okay, this equation is only true. Okay, this equation is only true if there are only two. Okay, this one and this one. Okay, there are only two branch. Okay, goes here. Okay, if three or more, you cannot use this. Okay, you have to use a different formula. So, but for this, you can use this. Okay, if you want to get I1, okay, you have to look here. If you want to get I1, you have to use R2. Okay, for voltage divider, you use the voltage you want. So if you look, V1 equals to R1 divided by R1 plus R2 V. Okay, but for current division, you have to flip it. Okay, if you want to get I1, you have to use the R2 value. But if you want to get I2, you have to use I1. Okay, for voltage divider, you have to follow. But for current divider, you cannot. You have to flip the value. Okay, and current division only apply for parallel circuit. Okay. Okay. For voltage is series. Okay. So make sure you know how to differentiate, how to use the voltage divider and current divider. Okay, how about if the branch is more than 2? Okay, 3, 4, 5, 6 and above. So you have to use this formula. Okay, for this formula, it's almost the same. Okay, for voltage divider rule, equals to Rn divided by R1 plus R2 plus R. Okay, multiplied by V. This is voltage division. Voltage division. But for current division rule, instead of Rn, you use 1 over Rn. You use, and for this one also 1 over R1. This is the reciprocal. Okay, you have to use this. Okay, this is the difference between the voltage division rule and the current division rule. So if you want to get the current across here, okay, In, okay, In over 1 over Rn, okay, this is the value Rn, okay, divide by the total. You have to reciprocal everything. Okay, then don't forget to multiply by the current here. Okay, this is the theory. Okay, this one I think you don't need to know, but if you want to know, it's just G is conductance. Okay, conductance is just basically 1 over R. Okay, this you just write another form of resistance. This is conductance, and the unit is mho. Okay, I think this one is not important, but this one sometimes is asked in the theory. So we continue with the example. Okay. Okay, I copy this first. So the question asks, find the power dissipate in 3 ohm. So you have to find the current, the output voltage, and the power loss at the V out. Okay, here. So how to do this? Okay, you have to use the teaching material you from the first week. Okay, you have to find the total resistance in series first. Okay, you have to simplify the circuit. You have to mix it into a one resistance. So you have to simplify the most simple series or parallel first. So this one is in parallel. Okay. So 6 parallel with 3. Okay. Okay, for this, you can use two methods. Last week, I think I don't show you how to, I only show you one method. Okay. So 1/3 plus 1/6. Okay. Inverse. Okay. But there is another way to use this, to solve this. Okay. This one is 3, 6. Okay. 3 multiplied by 6 divided by 3 plus 6. Okay. So this formula is actually, okay, R series parallel, okay, equals to R1 R2 over R1 plus R2. This is only true if the parallel is only 2. But it is if the parallel is more than 2, you cannot use this formula. Okay, only 2. Okay, but more you cannot use this. So, but if more, you have to use the formula 1 over Req equals to 1 over R1 plus 1 over R2 plus and the rest. So this one, this method. Okay, but for this case, you can use this. So we continue there. Okay, equal to. So you know how to use calculator, right? For the reciprocal. Okay, I have to change the it's okay. Okay, you have to know how to use calculator. Reciprocal, okay, 1/3 6 divided by. So the equivalent resistance is 2. So don't forget to redraw again. It is better if you are just learn about this. But if you already master it, you don't need to redraw again. But for this class, you have to redraw. Okay, I have changed this into a single resistance. This one become 2 ohm. This one 4 ohm. This one is 12 ohm. 12 volt. Okay. So you have to find the I first. So I equals to 12 volt. 12 volt. Okay, this one divide by 4 plus 2. Okay, in series, resistance in series. So you get 2 ampere. So this is 2 ampere. So you apply the Kichoff, the voltage current division rule. Okay, you get the current here. So you have to use the current division rule. So I out. So what is I out equals to? Remember, you have to flip because you want to find the current here. You have to use the resistance here. Okay. So 6 divided by 6 plus 3. Okay. I1 is 2. Okay. I is 2. You get? This one. So you use this. Okay. Okay, I out equals to 6 divided by 6 plus 3 multiplied by 2. You get 6 divided by 9 multiplied by 2. So 1.33 ampere. Okay, for this class, make sure that you put two decimal places. Okay, in each of your calculation, you need to put two decimal place. Okay, you can put 3 and more, but it's easier for me to mark, because if you put 3 decimal place, the answer will be different from 2 decimal place. So try to standardize the answer, which is only 2 decimal places. Okay. So how about V out? V out, you just use Ohm's law. Okay. You use Ohm's law. So Ohm's law is I out R. So equals to I out is 1.33 multiplied by 3, you get, okay, you get 4 volt. Okay, the voltage across here is 4 volt. Okay, and you have to calculate the power. Is basically P out equals to V out I out. 4 multiplied by 1.33. So you get 5.32 watt. Don't forget the unit. For current is ampere, for voltage is voltage, V, volt, and for power is 5.32 watt. Okay, W is watt. Okay, so for this case, you use the voltage a current divider rule. But I said before, these are only a theory toolbox that you have, a method that you have. You can to solve this circuit problem. You also can use the equivalent, okay, voltage divider rule. Okay, for example here, okay, okay, this is another way you can use it. Okay, plus minus 12 volt. Okay, this one is 2 ohm. Okay, because after you simplify this, you get 2 ohm. Okay, you can use voltage division rule. Okay, you can use voltage division rule. So V2 ohms is equals to, okay, V R2. Okay, so VR2 lah. Okay, this one is R1 and R2. Okay, R2 divided by R1 plus R2. Okay, and V. Okay, V here. Okay, you get R2 is 2 divided by 4 plus 2 multiplied by 12. Okay, you get 4 volt. So if you use voltage division, you also get the same answer. Okay, that's why this theory you can use any way you want, but you get the same answer. And after you get the voltage here, okay, you know the voltage across here is 4 volt. Okay, then you can just use Ohm's law here. Okay, you can just use Ohm's law. 4 volt, 4 divided by 3. Okay, you get 1.33 ampere. Okay, because the voltage is 4 volt, here also 4 volt. So you get the current and you get the power. This is how you use the Kichoff Voltage Law or Kichoff Current Law. Okay, both get the same answer. Okay, now we continue with another example. Okay. So if you can see here, this is a current source. Okay, current source is 20 ampere. Then it will divide into two parallel circuit. Okay, goes here one and goes here one. Then after that, it will divide into into more two parallel circuit. This one is two parallel circuit. So how to solve this? How to use the current division rule? First, okay, for this case, you need to know what is the current and okay. So this one we call I1. This one is I34. Okay, I12, I34. So to use a current division rule, you need to know the equivalent resistance here and here. So you use the formula. So 20 parallel with 30. Okay, 20, 30. Okay, 20 plus 30. So you get 12 ohm. So for second one, 10 parallel with 40. Okay, 10, 40 divided by 20 plus 40 plus 10. So you get 8 ohm. So what it means that okay, this one is basically 12 ohm, and this one is basically 8 ohm, the equivalent resistance. So now you can apply the Kichoff current law. Okay, it become like this. Okay, it's parallel. So how to do next is calculate the I12. Okay, this one I12 equals to, okay, remember you have to flip for the current law. Okay, current division rule, you have to use the flip resistance, the other side resistance. So 8 divided by 8 plus 12 multiplied by 20, the total current. Okay, so 8 divided by 20, so you get 8 ampere. So same here, you can use either current division rule, okay, or you can use Kichoff current law. So if you use Kichoff current law, so this one goes into, okay, this one goes out. So this one is negative 20 plus I12 plus, okay, I34. Okay, negative is means goes into the node, positive means goes out to the node. Okay, equal to 0. So I12 you already get. So basically I34 is equals to 134 is 20 minus 8. You get 12 ampere. Okay. So you already applied the first current division. So you have to apply again to get the current for I1, I2, I3, I4. So for this case, so I1 is equals to, remember, if you want to get the I1, you use the resistance at I2. So 20 divided by 20 plus 30 multiplied by I12. Okay. So I12 you already calculate. So 20 divided by 50 multiplied by, so 8. So you get 3.2 ampere. Okay. So I2, you can use Kichoff current law, or you want to calculate it again, it's okay. So I2, you have to use the opposite resistance. 30 divided by 20 plus 30. Okay. I12 also 8. So get 4.8 ampere. Okay. Is it correct? 2.2, 4.8. Okay. Next, the same also. Use the same concept. Okay. For I3 equals to 10 divided by, okay, this one 10. Okay. Because we want to find I3, you have to use the opposite resistance. Then 10 plus 40 multiplied by I34. So I34 is, okay, I34 is 12. 1 divided by 5, 12. So you get 2.4 ampere. Okay. Next, and the last one is I4. So you want to find I4, you have to use the resistance at the opposite side. So 40 divided by 10 plus 40 multiplied by I34, which is 12. So equals to 4 over 5. 9.6 ampere. Don't forget the unit. So you get all the answer. So next is, okay, another example. Okay, there is no example for more than 2. All the example is only 2. So I give you first, I give you an example for 3 resistance, 3 parallel resistance. So this one is 10 ampere. Okay. R1, R2, R3. So find the current IR3. Okay, this one is maybe 1 ohm, 2 ohm, 3 ohm. So if you for three resistance and above, you have to use the general formula because you cannot use the simplified formula. Okay, so you have to use, okay, you have to use this one. Okay, you cannot use this one. This one is only for 2. So make sure you remember this one is only 2. So you have to use this one. So because we want to find I3, so 1 over Rn. So 1 over R3 divided by 1 over R1 plus 1 over R2 plus 1 over R3. Okay, then don't forget the total current, which is 10 ampere. So R1 is, R3 is 1 over 3, 10 divide by 1 over 1 plus 1 over 2 plus 1 over 3. So use your calculator. Don't forget to view the previous video, which is in the week 1, how to use calculator to insert the reciprocal value. So 3 multiplied by 10 divide by, don't forget the bracket. Okay. Wait, I turn on another camera here. Okay, can you tell me whether you use this? Oh, sorry. You can see the calculator? Can you see the calculator? Can you write it in the chat? Okay, good. So okay, 1, don't forget, okay, because 1 over 3, okay, 1 over 3, so you just use this symbol, the x minus 1, you get the reciprocal, okay, multiply by 10, okay, divide by, don't forget the what you call, the bracket. So 1 reciprocal is just 1, plus 2 reciprocal plus 3 reciprocal, and close bracket. Don't forget the bracket. So you get the answer, and make sure your answer is in decimal point. So the answer is 1.81 ampere. Okay. So now you see the screen back. Can anyone reply it? See the screen back? The whiteboard? Okay. So, okay, there is question. Wait, I have to check the question. If you have a question, you can just open the mic, because I cannot check both of, I can check the chat because I don't have any assistant to see the chat. So Xia Yi Jing asks, we can use this method for 2 also, sir. What does that mean? Can you use your mic to ask me?
Hello, Dr. Rasman.
Okay. Hello.
I'm the one actually asking that question.
Okay.
Just in this method, we use this for the what we call the R that has 3, right? 3 or above for
Okay,
this
the R
method.
has 3 over. Okay.
What if we use this method with
Which one?
R?
This one.
Yeah. No, the
You
left
cannot.
one. The left one. The left
This
one.
one.
What if we use this method for resistance that is only 2?
Oh,
Is it
you
possible?
still get the same answer.
Oh, okay.
Yeah, because actually this one is simplified from this one.
Oh.
It's just a simplified version. If you derive it, you only 2 value, you will get this one. So it's, yeah, you can use this one is the general, you can use all, but for this one is for your simplification, easier for you to use.
Oh, okay.
Okay.
Thank you.
Okay, welcome. If you have any question, please use your mic, because I cannot check the chat. I don't have any assistant to help me with the chat. So 1.81 ampere. Okay. Okay, this is how you use the third one. The general formula for voltage division, current division rule. Okay, we continue with the last example. Okay, this one. Okay. So find I out and P out. Okay, this one is a little bit tricky. Okay, if you here, this one is in parallel. Okay, this one is in parallel. This one is in parallel with this. So first you have to use the parallel formula I mentioned last week. Okay, 70 parallel with 30. Okay. Okay, you get okay, this one 30, this one is 70, 30, 70 plus 30. Okay. Then use your calculator. 70 multiplied by 30 divided by 100 is 21. Okay. Then you have to calculate the 20 parallel with 5. Okay. 25, 20 plus 5. So 20 multiplied by 5 divided by 25, you get 4. Okay. So basically, you simplify this. So you get plus minus 20, 21 and 4 ohms. So from here, it become like this. Okay. Then you can get the current. So you have to find the current first, I. Okay. So this one is in series, so you just added it, and the resistance voltage is 50 volt. So use Ohm's law, I equals to 50 divided by 21 plus 4. So you get 2 ampere. Then 2 ampere. One is also 2 ampere. Then you can use a Kichoff voltage or current division rule. So you use current division rule to get the current here and here. So this one I1, this one is I2. Okay. So I1 equals to, remember to use the opposite side. If you want to get I1 here, you have to use the opposite side. 30 divided by 70 plus 30 multiplied by 2. The total current here.
Doctor, may I ask?
Yes, okay.
Why we have to take the opposite side?
Oh, because, okay, where is it? Okay, this one, the conventional one. Okay, if you derive it, if you use only 2 resistance, okay, if you derive it, you get this opposite side. After you do the derivation, you get this.
Okay,
Okay.
thank you, doctor.
Okay, welcome. So we stop first. Because sometimes they ask how to derive this. So I show you how to derive. Okay. How this can become. Okay, this. Okay, how to derive this. Okay. So example, you have 2 resistors in series in parallel. So I1 equals to 1 over R1 divided by 1 over R1 plus 1 over R2. So 1 over R1 divided by R1 plus R2 divided by R1 R2. Okay. then you bring this up, then you get R2. Don't forget I. Okay, I. And this one also I. I. Then R1 plus R2. So if you use this formula for two parallel resistance, you will get this. So you can see that if you get I1, if you want I1, you have to use R2. So basically, this is just derived from the general equation. Okay, so we continue with this one. So now after you get I1, so you get I2, the same here, 70. Okay, I2, you have to use the opposite one, 2. Okay, 70 plus 30, which one is 30? So this one is 7 divided by 10. So 1.4. So this one is 0.6 ampere. Okay, 3 divided by 30. Okay, so you get this one is 0.6. This one is 1.4. Okay, when you go here, it will combine. Okay, if you redraw this again, if you redraw this, it basically becomes, okay, this one is 70, this one is 30 ohm, this one is 20 ohm, this one is 5 ohm. Okay, you use Kichoff Current Law, okay, you get 2 ampere, then this one will become 1.6, and this one is 0.6, this one is 1.4. Okay, if you use Kichoff Current Law, okay, this one will 0.6 plus 1.4, you get 2 ampere back. So if you divide it again, you have to use Kichoff current law to get the I3 and I3, I4. So basically, you use 2 ampere as the total current here. Okay, this one is I3, I4. So I3 is equals to 5 divided by 20 plus 5. Don't forget the current is 2 ampere. Okay, if you redraw again, you get 2 ampere. So you get 0.4. Okay, 0.4 ampere. And I4 is equals to 22 divided by 20 plus 9. So you get 1.6 ampere. So you get all the current. Okay. Okay. This one is 0.4. This one is 1.6. So what is out? Okay. So you use Kichoff current law. So 0.6, this one is 0.4. So what is the current here? Kichoff current law, you get negative 0.6 plus I out plus 0.4. So equals to 0. So I out is basically 0.6 minus 0.4. Make sure you be careful with the direction. Okay. So if the direction is out, you put positive. Okay, positive. If direction is goes into the node, you put negative. So I out is 0.2 ampere. Okay. So you get the answer. How about the V out? So V out is you already get the I4. You just I4 then multiply by the resistance R4. You get I4 is 1.6 multiplied by 5. So you get 8 volt. So is it the correct? Yes. Okay. Okay. The slide is finished. Okay. We have learned about the voltage division rule and current division rule for this week. Okay. Any question? Do you have any question regarding the Kichoff current law, Kichoff voltage division rule and current division rule? How about the last week material, which is Kichoff voltage law, Kichoff current law, the Ohm's law, series parallel resistance? Do you have any problem with that? Okay, no question. Okay, I open this channel a little bit long, so you can log in your attendance. Okay.
I still don't not really understand about the Kichoff current law and the Kichoff voltage law, the theory about them.
Oh, okay. So Kichoff current law first. Okay. So Kichoff current law. So basically, okay, if you have circuit, okay, for example, it has many okay, many branch, okay, you have current goes into and current maybe go out. Okay, if you sum all this current, you will get 0. So basically, for example, I1, I2, I3, I4, I5, I6. So you have to make sure that the direction is important. For example, you assign goes into the node. Okay, if it goes into the node, it will become negative. Negative if into node. Positive is out of node. Okay, this is node, the point where everything meet. Okay, so if you write this, negative I1 minus 2 plus I3 plus I4 plus I5 plus I6 equals to 0. Okay, that is Kichoff current law. Basically, everything is equals to 0 if you sum the current. Okay. How about the circuit? If I give you example of the circuit here, example you have resistance, something like this. So this is I1, okay, I2, I3, I4. So although this one doesn't meet Okay, this one is considered one node. Okay, one node like this. This is one node. So if you write the equation here, I1, okay, so goes into the node is -1 plus I2 because it goes outside the node plus I3 minus I4. So you get 0. Okay, for example, said that this is 1 ampere, 2 ampere. So what is the value of this? So if you rewrite again, -1 plus 2 plus 3, okay, minus I4 equals to 0. So you want to get I4. So I4 is -1 plus 2 plus 3. So you get 4 ampere. So that is how you use the Kichoff Current Law. This is become 4 ampere. Okay, any you understand law and how to use it?
Total, because Kichoff Current Law is not I mean the current in the one node only.
At the current node. You cannot use another node. Okay, Kichoff Current
So
Law
got
at a single
many
node.
node leh. In this example, is it got many node?
Oh, if as a many node, you have to apply for each node. Okay. Okay. How I can. So plus minus. Okay, wait. Okay, you have 2 nodes, right? For this case, you actually have 3 nodes. 1. Okay. This is node 1, node A, node B, and node C. Okay, this one is also considered node actually, but it is not important node. Okay, so the important node will be have 3 branch. Okay, something like this. This one have 3. This one have 3. This one has 1, 2, 3, 4. You have 4 branch. So if you want to apply Kichoff Current Law, you have to apply for all. Okay. So this one I1, I2, I3. So this one I3, I4, I5. So KCL at node A. So KCL at node A is basically negative I1 plus I2 plus I3 equals to 0. And if you apply KCL at node B, okay, so negative I3 plus I4 plus I5. Make sure the direction, if goes out, it become positive, equals to 0. So that is how you apply KCL at different node. Okay, if you want C, okay, at C is also a node. Okay, this one is I5, I4. Okay, this one is I2. This one is I1. So basically, negative I2 plus this one is I minus I2 minus I3 minus minus I4 minus I5 is equal to 0. So if you apply KC at node C, okay, can you get this?
Yeah, I understand already.
Okay, already understand?
Yeah.
Okay, good. Now we move on to the Kichoff Current Law. Okay, Kichoff Voltage Law. You also don't understand, right? The Kichoff Current Law?
Yes. Yeah.
Okay.
I don't understand for that also.
Okay. also almost the same. Okay, I give you a simple example first. Wait, my PC is okay. So for Kichoff current law, Kichoff voltage law, KVL, okay, we use at mesh or loop. It's the same, mesh or loop. So for this case, you have to assign loop or mesh. So assume you assign I1, okay, I1, I2. So this one is loop 1, this one is loop 2. I1 and I2. Okay. And you have to be careful when you do mesh. This one is I1, this is the loop current. Okay, I1 and I2 is loop current. So you have to assign a different node. This one is IA, maybe this one is IB, this one is IC. Okay. So you cannot use 1 and 2. If you apply loop is 1 and 2, you have to apply A, B, C for the branch current. Okay, this is called a branch current. This one is a loop current. Okay, what I mean is, okay, now, okay, this one is R1, this one is R2, R3, R4. Okay, remember that I said you have to assign, okay, after you assign the branch current, automatically assign the positive and negative VR1. Okay, if the for resistor or any other passive element, resistor, inductor, capacitor, you have to make sure that if the current is assigned like this, you have to put plus RL. Plus the current goes into plus side. This one is also same, plus minus VR2. This one also same, plus VR3. This one is plus VR4. So if you KVL is basically after you assign all of this, if you do loop, okay, apply KVL, okay, KVL at loop I1, okay. So when you do loop, you meet negative, okay. This is Vs, assume this is Vs. So because it meet negative Vs, then because you do loop, you meet positive, then positive VR1, then you do a loop, okay, plus VR2, okay, equals 0. Same as Kichoff current law, okay. If before Kichoff current law, Kichoff current, all your everything that you add, okay, everything that becomes 0. But this one is for current. But for this Kichoff current law, Kichoff voltage law, of current is just and it is loop. So if you add this, you get 0. Okay. So far, you understand?
Yeah, doctor.
Okay.
Understand.
So same as here. Okay. If you do loop, okay, KVL at loop I2 or okay. So if you apply this, so if you do loop, you meet negative side first. So negative VR, then you meet the positive plus VR3, then you do loop, you round like this, then plus VR4. So equals to 0. So this is the Kichoff voltage law. Okay, how to apply it? Okay, for example, if you use this one, for example, I said that this, okay, volt, okay, this is maybe 5 volt, okay. So if you use this law, okay, if you use this law, negative 10 volt, okay, plus 5 plus VR2, okay, equals to 0. So automatically, if you use Kichoff voltage law, VR2 equals to 10 minus 5 equals to 5 volt. Okay, that is how you use the Kichoff voltage law. So example, if you apply here again, okay, for example, I said that this is 3 volt. Okay, so you look here. Okay, we have already do the loop here. So negative VR2 is 5 volt because we already write this. Negative 5, okay, plus R3 is, okay, if you can see here, R3 I assign a 3 volt, okay, plus 3 plus VR4. So equal to 0. So automatically, because of the Kichoff voltage law, you get VR4 equals to 5 minus 3, 2 volt. Okay, that is how you use Kichoff voltage law. Okay, so far understand?
Yes, yes.
Yeah. So that is how Kichoff voltage law and Kichoff current law. Okay. Any more question? Okay. Please sign in your attendance.
For
The-
just now, we want to calculate the 1 over Ohm's law one.
Oh, the reciprocal.
Yeah.
Okay, reciprocal. Okay.
No, I just want to ask how to calculate by the calculator. How to
Yeah.
use the calculator.
Because I need to show an example to show the
Okay,
calculator.
okay. Okay.
Okay. This one is 3 ampere. 10 ampere. 531 ohm. R1, R2, R3. So I2, I1, I3. Okay. So for example, if you want to get I1, okay. Wait, I need to set up the phone first. Okay, you can see the calculator? You can see the calculator?
Yes.
Okay. Okay, for I1, okay, I1 is basically I1 is equals to 1 over R1 over 1 over R1 plus 1 over R2 plus 1 over R3. Then don't forget to, this one is I. So I. So 1 over R1 is 1 over 5 multiplied by 10 divided by 1 over 5 plus 1 over 3 plus 1 over 1. I think 2 is much more easier to calculate. Okay, 1 over 2. Okay. So how to insert this into a calculator? Oh, you cannot see, right? First, wait. Okay, this one is how to write I1 equals to find I1 using current division rule. So if you use calculator, okay, this one, okay, so 5 reciprocal, this is the symbol, okay, multiply by 10, okay, divide by, okay, don't forget open bracket, okay, so 5 reciprocal plus 3 reciprocal here, and plus 2 reciprocal, okay, close bracket. So you get the answer. Don't forget to change into decimal point. So you get the first current is equals to, okay, the I1 is equals to 1.93 ampere. Okay, can you use the calculator right now? Can you understand?
Yes.
Okay.
Okay, thank you, doctor.
Okay, welcome. Okay, any more question?
Hello, doctor.
Hello?
I want to ask. Just now I seen the e-learning portal and you have posted in the discussion session, right?
Okay.
About a DC circuit that consists of 7 resistors.
Oh, the new one, the Kichoff Current Law, right?
Yeah.
Okay, okay.
Can we discuss about it, doctor?
Oh, okay. Okay, that
Because
question is actually from past year. It's quite difficult actually.
Oh, so we no need to take a look at it, or?
That question can come out actually.
Oh, okay.
Okay. Okay, this one, right?
Yes, doctor. Yes.
Oh. Okay, the question asks do not use mesh or nodal. Okay, this one it will be learned in week 3. Okay.
Oh.
It's quite so I think I will make a video. I will post it here. Can I post it later?
Oh, yes, doctor.
Because it's
Yes.
quite long to solve
Yes.
this. Okay, I have to make a special video for it.
Okay, doctor.
Okay,
Thank you so much.
welcome. Okay, I think that's all for today. Okay, if you have any question, feel free to WhatsApp me, but don't WhatsApp me at night because usually I already sleep. Okay, you can WhatsApp me in the week in the 8 to 5. Okay, thank you.
Thank you, doctor.
Thank you, doctor.
Thank you,
Okay.
doctor.
Thank you, doctor.
Welcome.
Doctor.
Thank you, doctor.